So I want to get this started by giving like a breakdown on like how Ash works and then delve a little bit into the code. By the way, this is like docs.ash.network/book. Public, it's publicly accessible. You guys can check this out. The first part is just like how to set up your environments, basically like the tools you need, how to use them, and like all the configurations that you will need. This just basically like goes through the basics of like how to deploy programs, how to create accounts, and how to interact with programs. But I'm gonna be focusing on this section, which basically like explains the different like data structures on Ash. So first of all, we've got like the program, which basically is a special kind of account that contains executable code. It's denoted by this field that is executable equals true. It's basically like eBPF bytes code that you can run, very similar to how Solana works. The programs on Ash are stateless, meaning you can read or write from accounts, but not the program's account. I'll explain more as we go. But yeah, every account needs to have an entry point, basically telling the network this is the function that you start executing first. And it's denominated using a macro called entry point. We'll go through this in the code and it'll be really very clear. Moving on to accounts. Accounts are basically unique 32 byte addresses to similar to Bitcoin. We use the same curve. So this is basically like the public key of the accounts, and you can store any arbitrary data on the account. An account is either marked as is executable true or false. Is executable true again means that this account is basically a program and it contains bytecode. And if it's not marked as true, it basically means that this is only a data account and it is used basically to like manage states and it is usually fed to programs. And programs can either like change the data in an account based on ownership. So yeah, some key concepts are accounts can store up to 10 megabytes of data, which can consist of either executable program code or like program state, meaning just like program data. So each account has a UTXO. The UTXO needs to be anchored to the state change on Bitcoin. If you guys like remember on the last talk, we basically said that we fix state sync problems using like this anchored UTXO. This is what we're talking about. Each UTXO, each account is basically anchored to Bitcoin through this UTXO. And you can create new accounts, allocate space in those accounts up to 10 megabytes, and only like modify accounts. The accounts look like this. You can see that all these references are immutable, besides the data field, which you can change from within the program. This UTXO in here is basically has the accounts key encoded inside the script pub key. This makes the validators on the network basically accountable for what's happening on Bitcoin. But yeah, it's a UTXO. It has a data field that you can change. It has an owner, which is basically another account that owns this account. And these are fields that you pass into the instruction, either a signer, meaning that this account has signed the transaction, is writable, meaning like if you can write on it or not, or is executable. Again, true means program, false means it's just a data account. This is the entry point that I was talking about earlier. It's basically like indicates to the program which function to execute first. And it basically needs to respect this formats, program ID, which is basically the public key of the program, the list of accounts that you are trying to feed into the program. These are all accounts and instruction data. Yeah, and you basically like construct instructions as follows: program ID, accounts, and data. And these like map one-to-one to these, by the way. But yeah, I think